Okay, so section chapter 2-1 has to do with relations and functions. So we're just going to look at some definitions. So what is a function? A function is a relation in which each element of your domain, which all your x's, is paired with exactly one element of the range, which are your y's. So x doesn't repeat. So for every x you have, you've got one element in the y that pairs up with it. So a one-to-one function is one that each element of the domain pairs to exactly one unique element of the range. So kind of like what I just explained. So just we're going to look at a little bit another definition just a little bit in detail. So look at an onto function. An onto function is when each element of the range, so now looking at the y first, corresponds to an element of the x of the domain. So we'll look at some examples to see when a function is one-to-one or when it is an onto function. And if you have the situation where they're both one-to-one and onto, then every element in the x, all the x values, right? So the elements in the domain are paired up with exactly one element of the range. And each of the range is paired up with a unique domain. So an x is paired up with a y paired up with the x. So let's go ahead and look at an example. So let's say we have these points from something here, and you're trying to determine if these are functions, are they one-to-one, are they onto, etc. All right, so let's see. So first of all, we need to study the domain and the range to see what we have. If you notice, the domain elements D, domain is X. So the domain are all these first numbers here. So I wrote them here as a set. So the -6, -5, -3, -1, and 6. Well, if you notice, you've got 1, 2, 3, 4, 5 elements in the domain, but 1, 2, 3, 4, only 4 elements of the range, the y's. So is this a function? Well, yeah, it is, because every x is paired with a different y. So you don't have like a -6 with -1 and -5 with -1, then we'd have a problem. But if you notice, each of these are paired with two different numbers, so we're okay. Now, you're saying, well, look at this here, -5 is paired with -9 and 6 with -9. Well, the -9 is the range, that's the y, that's the one that's repeating, not the x. So we're okay. Remember, in a function, you check the x. So is it a function? Yes, it is, because each of the domain values, each of the x's, is paired with one of the y values. Now, is it one-to-one? Well, no, it isn't, because each domain is not paired with a different range. So you would have to have, we're missing one, right? We're missing some kind of number over here, because we don't have, we're missing, we don't have enough numbers to pair up with all these domain values. But is it onto? Yes, it is. It is onto. Why? Because now we check the range. The range values correspond with one of the domain values. So one-to-one, no, but onto, yes, because onto checks the range that are paired up with the x's. The one-to-one, you check the x's paired up with a unique y. So what is a discrete relationship? Well, a discrete relation is a graph that the points are not connected. So something like this kind of graph would be a discrete relation, where a continuous relation is a graph in which the domain has an infinite number of elements, and the relation can be graphed with a line or a smooth curve. So this right here, we would consider a continuous relation, because again, there's no breaks or anything like that, like it is here, whereas discrete. So how can you tell if you have a function in these two type of graphs? All you do is draw a vertical line. That's called the vertical line test. So draw the line somewhere in the graph. So I could have drawn it here, I could draw it here, I could draw it here, here, vertical. So it have to be straight up and down, and see how many times it touches. So a vertical line that touches once, you've got a function. So if you notice, if I draw my line here, it only touched once. If I draw it here, it touches once, here, etc. But notice how for this picture, a parabola that is on its side, if I draw a line, look how many times it touched the graph. It touched it once, and it touched it twice. So that is not a function, because it touches twice. So you do a vertical line test to see if you have a function. Touch once, you've got one. Touch twice, not a function. So just a reminder of your independent variable. So if you notice, we've been calling x a bunch of different things now. X is your domain values, x is an independent variable, and also the y is your range values and also your dependent variable. So you're also going to see that sometimes we're going to use function notation. And in function notation, to tell somebody, hey, I've got a function, you don't have to just put the letter y. You could turn it into f of x, and that's how you read this, f of x. So if you ever see an equation started with f of x, then they're kind of telling you, hey, you've got a function. So now let's look at your packet. Your packet has the vocabulary that you're going to need, and also here's the definitions that I just mentioned, whether you have a one-to-one, an onto function, or both a one-to-one and onto. So kind of look over that information to get more details. And so you have some practice problems here that they've included. They also mentioned the vertical line test. Notice how they drew a line that's vertical. If it touches one time, you've got a function. It touches two times, you don't have a function. And so you're going to have some different examples here, kind of explaining some of the extra things. Now, to draw a graph, I know some of you may not have a calculator, but that is not entirely necessary. You can pretty much draw a graph just by going into the functions and looking at certain things. For example, here, in this particular question, graph y equals 2x plus 5, you'll notice some things about the equation. First of all, and you'll get more notes later about this, but if you notice this right here, that's called, this is a linear equation. It's in the form y equals mx plus b. Sorry about that extra line. Where this is always your y-intercept. So I know that my equation is going to cross at 5. So 1, 2, 3, 4, 5, that could be it. That could be it. This one's not crossing at 5, so I know it's not that. And this one should be crossing at 5, and it isn't. So now I know it's linear because x is to the first power. And so I'm going to go ahead and draw a line that has a slope of 2. That's what the number here in front of the x stands for. So if my slope is 2, I just turn it into a fraction. And therefore, I know I'm going to rise 2, I'm going to run 1. And so basically, I go up 2, run 1. So then this looks like it could be my equation. I rise 2, run 1. Whoa, wait a minute. That line is the other way. Well, if you notice, it's going down to the right. So this has a negative slope. This slope is positive. So therefore, it has to be this line that's going up. So the correct answer is letter A. So you're going to see some other examples here where it says to evaluate the function, and it gives you the example here. That just means to solve what's the x negative 2, what does it do in the equation? Remember, this is like f of x, so x is negative 2, plug it in. And here they did it for you, and that way you can follow that example. Same thing here, instead of just x being just a number, now it's 2t. So anywhere you see the number or the variable x, you're going to put in that number and the letter, so 2t. Substitute it in and, of course, solve. And there's some more examples for you to try. So once you get to the study guide and intervention questions, it gives you, again, a little explanation on what is a one-to-one, what is an onto, etc. And so kind of read over that information as well. So here you're going to determine, just like I showed you the example earlier, whether it's one-to-one, onto, both, or neither. Then some of the examples you're going to be given are to graph. And so let's just go over the first equation that you may have not seen since algebra. I taught my students whenever you have something like number 1, y equals 3, you think of two words, ahoy or a vux. Well, if you notice, this is a y, so it is this situation where you have a horizontal line with a 0 slope. that's how you know what your picture is going to look like. So you go to y equals 3, 1, 2, 3, right here, and you're going to draw a horizontal line through that point. Sorry, it's a little hard to draw with this pen on the computer. If I had an x equal to something, like let's say x equal to 2, this has nothing to do with this problem, but that just to, explain, then you have this situation. You have an x where it's a vertical line with an undefined slope. So that's where you get that Buck's word. So to help you remember which way to graph those, just use the Hoy and Buck's, and that way you can recall that. So in this situation, if I had this equation, let me just change the color. If I had the x equal 2, then it would be, you would go on your x, 1, 2, so right here, and draw a vertical line. Sorry, they're supposed to be straight. It's just I'm trying to draw with my pen. You don't need the blue. You can ignore the blue. I was just trying to show you how you can graph these quickly. So here you just substitute values. Same thing within the practice. You just continue practicing some more of those problems. See here, like I was explaining right now, that's a Buck's situation. So just go ahead and do that when you get to that. All right, so then now it's asking you to find the value of f of x and g of x. So let's just do any random one. I can just start with the first. So f of 3, so I'm going to be using this. Remember what they did was substitute anywhere they saw the x, they put a 3. So I'm going to do the same. So I end up with 5 over 3 plus 2. And so f of 3 equals to 5 divided by 5, which is equal to 1.